Alrighty, so let's switch these two and run our tests. And we've got a bunch of errors. So onToggle is not a function. All right, that's nonsense. Let's figure this out. So we're combining control props with our existing solution. The reason I say it's with a state reducer is because they actually cover similar use cases. The state reducer is actually pretty much unnecessary if you have control props. The reason that I like to put them together, though, is because if I need control props for some reason, then a state reducer is probably a simpler way to handle some use cases. And so with control props, people have to put that state somewhere, like where this on state is going to live. It's got to exist as a state property of some other component. And with a state reducer, you don't actually have to do that necessarily. And so having them together makes it so users have a little bit more choice in how they're using your component. Yeah, if you want to be able to update state of a component from the outside and like totally uncontrolled by the toggle component itself, control props allow for that. So specifically in our case where we want to synchronize these two, this component state is getting updated from the outside in. And a state reducer can't do that. But a state reducer is a little bit simpler from a user standpoint for other use cases, so I like to have them both. Okay, cool. So now that, so before we didn't have an onToggle default because like this component's totally worthless without being able to know when the toggle happens. But now they can know when the toggle happens from a new prop that we're going to expose called onStateChange. And so we're going to add a default for both of those. And they'll just be no-op functions. And if we're using typing, then we might be able to say you have to have one or the other. And that type definition would be kind of silly looking. But yeah, that's generally the idea. You want one or the other or both. It's fine to have at least one, though. Okay, so we've got our defaults. Now let's add our isControlled. And here we'll accept a prop. And we'll return this dot props. Prop is not equal to undefined. And then we'll have that get state that we had before, except this one is going to be a little unique because when we are using the state inside of our updater function, we need to get state from its canonical source, and that could be from props or it could be from internal state, it could be a mix of the two. And so this get state function will actually accept a state argument, and that will default to this dot state, so all the other places that are using it can just call it, and it'll default to this dot state. But when we call it inside of our updater function, we'll be able to provide the state from our updater function. So in this case, we're going to return object dot keys or entries or whatever you want to do. I'm going to just do keys. State. We'll do entries. And with this, we'll reduce that into an object. So that's our new state object right there. And so we'll call this new state. That's our accumulator. And then we'll destructure the key and the value from our entry. All right, sweet. So then we'll need to return the new state. And we'll say if this dot is controlled, the key. So if that particular part of state is controlled, then we'll say new state at that key is going to be this dot props at that key. Okay? So if this state is being passed in from props, then that's our new state is going to have its value from props. Otherwise, it'll get it from state. And actually, that's what the value is going to be. So, ta-da. Okay. Cool. So that is get state. An observant question was asked, and I want to share that really quick. Why you can't do this. Somebody suggested perhaps we could do this. Return object.assign just this is our new state, and then state and this dot props, and then this dot props wins in the case of conflicts. The problem with that is this dot props has all of these extra properties on it, and so those aren't part of our state. We'd have to pluck those things out. So the amount of code, it's 6s. So you could do it either way. So create the state object with all the props and then remove the extra props or something. But yeah, I like this better. So we're only dealing with stuff that's in our state. Okay, cool. So let's get rid of that. Make sure we're getting this all done. So anywhere that we're using state, we want to use like combined state. So I'm going to make combined state this dot get state with the state. So in our updater function, we're past the current state in this batch of set state calls, and we're going to call get state for that state in the batch of get state calls. And so now it's combined between the state that's coming internally and the state that's coming from props. And that's what we'll use for everything else. So we'll call the updater function with the combined state. We'll call our state reducer with that combined state. Yeah, so far that's all the updates we need to do there. Okay, cool. Get rid of that. Okay, so now this is where things are going to get a little tricky. Yeah, this is actually the reason that I was up till 2 last night, because I was rethinking things and spent 2 hours working on it and then decided this was the best way. So code very similar to this is in Downshift and is working great. So we're going to create a new variable up here called all changes. And rather than create a new variable called reduce changes, we're going to just assign all changes to that. So this is all changes. By all changes, it means it includes the type. And we're going to need that here in a second. So let's get rid of this. And then we'll do all changes. So now we're removing the type from all changes to get only changes, and we return that. Let's see. Sorry. I think I confused myself for just a second. Oh, right. So because our component is only managing the state for which it is managing, in an effort to avoid unnecessary re-renders, we'll we'll chip away this this only changes, or really we'll just chip away the all changes object down to only the stuff that's being managed by ourselves, because that's the only state we want to update. So in the case of Downshift, if you are controlling the isOpen state and somebody clicks on the menu thing, we want to let the owner of this component know, hey, the user clicked on the menu, so I suggest that you open the menu, but I don't want to manage that state myself. So I'm not going to, I'm calling set state, but I'm going to return null instead of triggering a re-render, because it may be unnecessary. Maybe the owner of this says, hey, when the user clicks on the thing, because something else is going on, I don't actually want the menu to open up again. And so that's why we're going to split up all changes between changes that are coming from, or changes that are controlled by our internal state and changes that are controlled by props. And then only those that are controlled by state internally are those that will actually return from our set state call. Does that make sense? It was a lot of words, so I'm sorry to be talking so much about state. I probably use that word a lot. So to accomplish this, we're going to, let's see. Rats. I'm just going to look at it really quick to remind myself. Yeah, that's what I call it, non-controlled changes. Okay, so it actually looks kind of similar to our get state. So non-controlled changes, equals object dot entries or keys, or however you want to do this, of all changes. Actually, we'll just do our combined state, because that's ultimately, that's all that we really care about. All changes includes the type, and we don't want to return the type anyway. We could actually do this and do only changes, but it really doesn't matter because all we really care about are actually the keys. So there are like a lot of different ways you can do this, but the general idea is let's just get the changes that are not controlled. Okay, so then we'll we'll reduce this into another object, and so we'll just call this accumulator, and that's going to accept our state key, and then we'll start out with an empty object, and we'll return that accumulator. Here, let me give myself some more room here. Okay. Great, so with that, we'll say if this dot on, or let's see, is controlled state key. So if this particular piece of state is controlled, then we don't want to actually do anything. So we'll do the opposite of this. So if it's not controlled, then we'll, at the accumulator, state key equals our all changes at state key. And this is what we're going to use here. That's what we're actually going to be returning. Okay, coolio. And then now we can update the state, and we only update the state that's not controlled, and so that's great. But the person who, or the consumer that's controlling the state needs to know, when should I update state? The user's done something. I need to know, based off of your own internal logic, when should I think about updating state. And so that's where we modify this slightly. So, and this is why we created this all changes variable up here, so we can access it inside of here. So we'll say this dot props dot on state change all changes. So now it knows not only what changes took place, but because this all changes includes the type, it'll also have the type, so they can make decisions on whether they actually want to update their own version of that state or not. And it includes all the changes, not just those that are controlled, because it's probably useful. In addition, just for fun, we can also pass this dot get state and helpers, because I added that to downshift, and I remember there was some point that I was really happy that I did. I can't remember why, but it's just kind of a useful thing. Like based on state, I want to call the toggle again or something like that. So it can be useful for some cases. Okay, let's see if that passes our test. No, I think we're still missing a couple pieces. All right, this dot state, all of these should be this dot get state. There. Like magic. Ba-la-la-la. All right, so what questions do you have about this? Yeah.
Do you always use, like, online, where is it? 49 there, object.keys.reduce. You're doing this to get an array out of objects so that you can reduce it, and then sort of combining it back together into an object.
Mm-hmm.
I know, like, Lodash or underscore have like a reducer that you can use directly on an object. Do you ever use anything like that? I guess maybe not when you're developing a library. But.
Yeah, exactly. That's exactly right. Good question, though. So yeah, Lodash. I'm sure there are like 30 npm modules that all can do this too. So if this were like really complicated, I might find a small library that could do that. But just like you said, it's when I'm using a library or when I'm writing a library, then I want to just kind of use the raw APIs. It's not like too much more complicated than using reduce from Lodash. It's like reduce.
It's just a little verbose.
Yeah, but it does read a little bit nicer, so I can see how that could be valuable. If you are doing this within your application and it already is using Lodash, then I wouldn't have any qualms with somebody wanting to just use Lodash reduce or something. Yeah, good question.